This video is part 4 of 5 parts which introduce how to use trigonometry to solve problems with right angle triangles to find missing sides and missing angles. Now hopefully you've watched the other 3 parts before you've gotten to this part so that the things that I say will make sense, and you may think that you're seeing the same thing again because part 4, like part 3, is about finding the missing side of a triangle. But it's slightly different. And I want to identify the differences. And I've also got this word ding dong here, and there's a reason for that as well. So if you've watched my previous videos, you will know that even though there are 3 ratios, sine, cosine and tangent, we are learning about the 3 types of trig problems using only tangent to start with. So all of the questions from now on, you don't need to think about what rule is being used, what ratio is being used. You just need to identify what the differences are between them when you see the question. So this looks a lot like previous questions. It looks like the type 1 questions. We've got a right angle triangle, we've got an angle, we've got a side, we've got an x, an unknown. And the first 3 steps are exactly the same. Label the triangle, write the rule, substitute in the rule. I've got a little ding dong over here, and there's a reason for that in a moment. So what we're going to do first, we are going to label the triangle. So our right angle can be made into an arrow, which is going to point to the hypotenuse. So we're going to pick up the H and put it over here. And then here's our angle, and the side that's adjacent or next to that angle is there. So we're going to call that adjacent. And over here, tennis ball, this is the opposite side. Now some of you who are really cluey will have already picked up that there's a difference between this and the previous type. Second step, write the rule. Well, in order to identify the rule, we need to put circles around the information that we've got. So here we've got an X here, and here we've got 17 centimeters. So we've got the opposite side and the adjacent side, and if I hadn't told you already, that indicates to us it's going to be the tan ratio that we're going to use. So we write down that rule. Then we're going to substitute into the rule. So in order to do that, I'm going to move these green boxes out. So I've put the 52, the angle, in where the theta is, and the opposite side, I've been very careful, and I've noticed that the opposite side has got a 17 on it, and the adjacent side has an X on it. And I don't know whether you've noticed already, but already this is the big difference. This is the ding dong that I'm talking about. This is the difference. Let's flick back to type 2. And we'll see that when we substitute it into type 1 question, flick back to type 1, please excuse me, the X was on the top and the 13 was on the bottom, and that allowed us to go ahead and solve the problem. But now the X is on the bottom and the 17 is on the top. And that's what I mean by ding dong. As soon as you see that X on the bottom, that tells you, sit up and pay attention. We're doing something different this time. We're not taking the 17 onto the other side like we did with type 1. This time we have to do something different. Now something different that we're going to do is called swap. It's going to allow me to do this. Swapping. So what we're actually doing is we're taking the whole of this tan 52 and we're swapping it with this X. We're doing a swip swap. Whoops. We're going to swap those 2 around. So on the next line we've got X is equal to 17 on tan 52. Now you may say to yourself, well, I'm sorry Miss Rowland, what's going on there? Since when can we just swap things around? Well, let me prove to you that it is correct. So let me start with this statement down here, which I hope you will agree is true. 4 is equal to 12 divided by 3. Now, I'm hoping everyone agrees that that's true. 4 is 12 divided by 3. So this is sort of like this fraction here. I've got a number, tan 52 is just a number, is equal to another number divided by something that will be a number. But watch carefully what happens when I do a swap. Let's put the 3 over there and let's put the 4 here. 3 is equal to 12 divided by 4. It is. 3 is equal to 12 divided by 4. So what I'm saying is that provided you have got a number is equal to something divided by another number, the denominator here and this answer over here can be swapped around without changing the integrity or the correctness of the equation. So I'm not doing anything wrong here. I'm not breaking any rules. In fact, I could probably do 2 lines of algebra to go from here to here, but we're trying to identify a legal shortcut. There's not many shortcuts I'll allow you to do, but this is one of them. So when you see that x on the bottom of the fraction and the big bells ring in your mind, you're thinking to yourself, ding dong, swap. Just swap these 2 over. So my next line is x is equal to 17 divided by tan 52, and if I put that into my calculator, now remember my calculator, it's almost as old as I am, really ancient. So I've got to do 17 divided by, now remember my calculator goes backwards, 52 tan, but I can see that it's done the correct thing up here, and then press equals, and I get the answer 13.28. So let's go through that again. Whoops, a daisy. Let's put those back in the right place and perhaps get rid of this box here. First step, exactly the same. Second step, exactly the same. Third step, exactly the same. Be careful that you're actually substituting incorrectly. Sometimes people get on a roll. They think the x should belong on the top. It'll always belong on the top. Not necessarily. And then, once you see the x on the bottom, and the big bells ring in your mind, then you need to swap those 2 over. X is equal to 17 divided by 52 into your calculator, use the units on the question, and you are done. So, here are 4 questions for you to practice. I want you to pause the video. I want you to copy the triangle and all of its labeling onto your book or on your page. I want you to follow those 3 steps. Label the triangle. Write the rule and substitute into the rule, and then, because I've told you they're all type 2, look out for that opportunity when x is going to be on the bottom. Okay, pausing the video. Are we pausing? You need to pause. Okay, if you remember from the previous video, my writing now is going to become appalling. So I've given myself a whole lot of space here so that I can write this, and you're going to forgive me for the really bad handwriting. It's just the device I'm using. I'm blaming my tools. Okay, so what's the first step? First step in any trig problem, label a triangle. So let's make a little right angle out of this, and that'll tell us that this is the hypotenuse. There's our angle. This is the side that's next to the angle, and over here that must be the opposite side. Let's put a circle around the information that we've got. We've got that, and we've got that. Opposite and adjacent. I wonder which rule uses opposite and adjacent. Of course it's tan, because we're practicing everything with tan. So tan theta is equal to opposite over adjacent. Say the rule, sing the rule, dance the rule. You've got to get it into your brain. Oh, really poor writing. Tan of 38 is equal to opposite 19.8. Shush. Over x. Now, ding dong, x is on the bottom, isn't it? So that means on our next step, we're going to swap the whole of the tan 38. Not the 38 on its own, it's locked inside the tan 38. And we're going to swap those over. So on my next line, I'm going to have x is equal to 19.8 divided by tan 38. Get our trusty calculator out. Trusty old-fashioned calculator. 19.8 divided by, my calculator goes backwards, yours will go forwards, and equals, so 25 point, how many decimal places? We need 2 decimal places because there is 1 decimal place in the question. 25 point, should have paid attention to that, shouldn't I? 25.34. 0.34 meters. Okay, how did you do? Let's put our bold dash hat on and check to see whether it sort of makes sense. This is an angle that's less than 45, so it's going to be opposite a small side. So this side is more likely to be bigger than this one, and 25.34 is bigger than that one. I'm going to pause the video now and I'm going to get the other three answers for you so that you can check your other three answers that were correct. Okay, so here we go. I've got the answers to the other three questions. This is the first answer to the first one that we already did. These are the answers to the other three questions. Now notice with this one I've got one decimal place. You could have done, I think it was 12.05 perhaps, but there were no decimal places in the question, so I always do one extra decimal place. So from 0 to 1 decimal place. And this one had no decimal places either, so I rounded it to 1 decimal place. This one had 1 decimal place, so I rounded it to 2. It may depend on what your teacher prefers. I know if you're one of my students, I prefer there to be 1 extra decimal place than the number of decimal places that occur in the question. So we are near the end of our journey through trigonometry. Only one more video to go, and I'm hoping that you will watch it. Thanks for watching.